Typecasting. Conversion of one data type to another data type is typecasting. We can easily convert a lower data type to a higher data type without any explicit conversion. For example, byte can be converted into integer, float or double without any explicit conversion. And this conversion is done automatically or internally by the compiler itself, and there is no loss of data. But to convert a higher data type to a lower data type, for example, if you want to convert double, float or integer to byte, explicit conversion is needed, otherwise we are going to lose some data. So let's see how can we use typecasting in our program. Hash include stdio.h, a header file, int main. I'm taking two integer variables, integer a and b, and I'm taking two float variables, float f1 and f2. Now I'm assigning a equals to 10, and to f1 I'm assigning a. This is implicit conversion. Because a is of type integer and f1 is of type float, so there will be no loss of data, and this integer will get converted into float internally by the compiler. Printf \n f1 equals to %f comma f1. Now I'm assigning b equals to, let's initialize f2 with 25.5678, f2, and then printf double quotes \n. b is of type integer, therefore %d I'm using, comma, here I will print b. Return 0. Save the program. Build it, not showing any error, and run it. So value of f1 is 10.00000. That means 10 was converted to floating point number, and second one is 25. It was 25.5678 like that, and it is converted to an integer value, and there is loss of data. Now we'll see other example of typecasting. So I'm deleting my previous program. I have taken two integer variables and one float variable. Printf within double quotes \n, enter two numbers. Scanf within double quotes %d space, again %d for second integer variable, comma, ampersand a is our first integer variable, comma, ampersand b is our second integer variable, close the bracket and put semicolon. Now f1 equals to a divided by b. Printf \n without typecasting value of f1 equals to f1 is of type float, so percentage f, and here I will put comma and then f1. Now here I will do typecasting. f1 equals to float and then a divided by b, put semicolon. This is with typecasting. Value of f1 equals to this. Save it, build it, and then run. Enter two numbers. I am giving 19 and second number I am giving 2. So without typecasting, the value of f1 is 9.000000, and with typecasting, value of f1 is 9.5000000. We will rerun this program. Now I am giving value 15 and second time I am giving 2. So without typecasting, value of f1 is 7.000000, and with typecasting, value of f1 equals to 7.50000.